Alright, this lecture is on breadboarding. Something new to you guys. We're going to be doing a lot this year, more of a hands-on activity. Once we actually design our circuits, we actually have to make a prototype. So we have to make something that works. So we're going to talk about what is breadboarding and why use a breadboard. And then in class, we're going to do some simple breadboarding activities. There's a video you'll watch at the end of this as well, and a few other things. So we're going to breadboard our series in parallel circuits. Alright, so what's a breadboard? It's really just a prototyping board that you can use over and over and over. Alright, so instead of fabricating a really expensive board and something doesn't work, you're not making the right connections, instead of spending all of that money and fabricating it, alright, first of all we simulate it on the computer, and then we actually have to make that sure that everything works physically. Alright, so we breadboard the circuit, so we're building a prototype. Then we take that prototype, then you make your actual board with your permanent circuits on, much like the ones that we've soldered and things like that. So what if we're looking at how a breadboard works? So there's kind of a cutaway view here that you can kind of see, and they're all metal jumpers that are tied together under there. And every breadboard that we're going to use is just like this one. There'll be a long one on the outside or a long two, so we can take a look and see in that bottom right hand side there's a long one, and then they all go across. Okay, and then there's a divider in the middle. That's there so that we can put our integrated circuit chips across them, so that we can span across. Because if we were to put our integrated circuit chips just in one side, it would short them all, because we would be putting like the same connection into itself. It really wouldn't work. Okay, so it's imperative that we understand how the breadboard connections work. So in class, I'm going to walk you through step by step breadboarding the circuit. Alright, so you're going to follow me, or I'm going to put an exact video that I want you to follow, or those sort of things. The video at the end of this is more just a tutorial, so you can kind of get an idea of what a breadboard looks like and being able to place some wires in. It's a little confusing at the beginning, but once you get the hang of it, breadboarding really isn't that bad. You just got to be able to, it's kind of like connecting the dots. So like we saw in the previous cutaway picture, alright, what these red lines represent is actually how the breadboard is connected underneath that you can't see. So there's going to be holes here that you stick the wire in, and it's going to have connections underneath. So if we look all the way across the top and the red line at the bottom, those are all the same connection. So whether I put a wire in pin 1, in pin 5, in pin 10, in pin 15, in pin 20, and pin 23. It's not labeled, but there is a pin 23 there. If I put a wire in any one of those, it's going to be the same connection. Alright, but let me clarify. The connection at the top is a different connection that is at the bottom. So the bottom 1 through 23, it's its own grouping. The top 1 through 23, it's its own grouping. So we might put the positive into pin 1 and the negative into pin 1 on the top, and the negative 1 into pin 1 on the bottom. That means on the bottom, everything there would be a tie into the negative. Everything on the top from pin 1 to 23 would be a tie into the positive. Alright, now we see all the vertical reds. So there's 1, A, B, C, D, E. Okay? There's those 5 that are right there. Those are all the same connection. They are not the same connection as 1, F, G, H, I, and J. That divider in the middle makes it so the top part is separate from the bottom part here. So pin 1, okay, or column 1, row A, B, C, D, and E, those are all the same connection. Just like pin 5, okay, or column 5, row A, B, C, D, and E in column 5, that's all the same connection. Down below, if we look at column 10, F, G, H, I, and J, they're all the same connection. So whatever wire I put in there is going to have the same signal. So if I put a wire into F10, and I can put another wire into J10, and those will have the same signal that I need to send out to other parts of the circuit. Alright, and you'll get the hang of that as we breadboard. Alright, but I really need you to concentrate and kind of understand how the breadboard's connected underneath. Okay? So 1A and 2A are completely different signals. 1A and 5A are completely different connections. Okay? 10A and 1A, completely different connections. So that's very important as we go through this. This is probably the hardest part to conceive, and this is where you're going to struggle a little bit with breadboarding, is making sure that you're smart about where you're making those connections. Okay? So why do we breadboard? Well, we talked about it a little bit. It's less time sometimes, right? You'll find that out when you're doing your projects that we do in here to breadboard the circuit, but it's always good to have a working prototype before you start fabricating a bunch of circuit boards. Alright, so anytime we talk about a PCB, that's a printed circuit board. So the breadboard companion, the die roller, and if we do the piano or the random lights, all those things that we soldered, those are PCBs, printed circuit boards. To an extent, we make them printed circuit boards because we solder them and complete them. But like what's in your phone, printed circuit board. What your motherboard is on your computer, printed circuit board. Alright, so when they do a motherboard for a computer, they don't just, start printing a whole bunch of them. They don't necessarily breadboard one, okay, that's kind of hard for them because there's a lot of different connections. But they make a prototype board, alright, so when you guys are looking at software or something, it might be the beta version, okay, something that's being prototyped or tested, okay. But it allows you to see all the different connections and see what's working and what's not. Sometimes in theory something should work, and then when you put it all together in reality, you're like, that's not going to work. I got to do this a little bit differently. So it kind of helps you with layout and doing that sort of thing as well. Another advantage of breadboarding is you can make a quick adaptation or a quick change if you need to. If you have a printed circuit board, you got to print a whole new board. So if you need to move a couple wires around on a breadboard or change a couple resistor values, you can do that real quick. The printed circuit board, you got to desolder, put the other one in, resolder. That takes time. Okay? Changing a couple capacitors or resistors by hand is a lot easier. Okay? You can also take measurements better. Alright, so when we have to use a multimeter, we can check for voltage drops. For us, when we're breadboarding in here, since we're doing digital electronics, we're going to just be looking for, 1 volt, or 0 volts or 5 volts. Because that's what we're going to be using to do our controls. So 0 volts tells me that it's not on. 5 volts tells me that it's on, so I translate that to zeros and ones. That's going to come up real soon here when we start getting into our logic gates and things like that. Alright, keys to breadboarding, and I'll talk about this more as we go. Alright, use as few jumper wires as possible. You're going to notice when we start doing some projects in here, your breadboard might start to fill up with a lot of redundant wires or things that you don't need. There could be a ton of wires, and you got to make sure that you want to use as few as possible. You still have to build the circuit, but make sure that we're not making any unnecessary connections. You want to keep all your jumper wires as short as possible, so we're going to cut the wires, strip them, and make sure that they sit flat. So when we get to breadboarding, I'm going to show you what's a good breadboard looks like once it's done, whether we have all the wires sticking up and it's messy and you can't see what's going on, or nice, flush, neat. Same thing that applies in real life though. So if we go and look at an electrical panel, alright, you don't want to open one that just has wires chaotically going everywhere and just jumping around. You open up a control panel, alright, everything is nice and neat, the wires are smooth, they're going and connecting where they need to, alright. It makes it a lot easier to troubleshoot, alright, and it makes it a lot easier so that you don't bump something and pull it out and screw up the whole circuit as well. So a lot of different reasons why we do that, alright. We got to make sure, like I said before, we place the integrated circuit chips in the middle of the breadboard so that we don't short them, alright. Some of you guys are going to blow some chips up and think, not like big explosions, but you're going to fry them, alright, and that's okay, we'll replace them. But if you're careful and you follow the directions, those kind of things don't happen. The best thing that you can do, and most of you will probably skip this step, even though it's one of the most important ones when you're breadboarding. Work from a schematic and check off the component and the wires as they are implemented on the board. So when I make a connection from pin 1 to pin 8, I highlight that on my schematic, mark it off. That way I know that it's done, and I've double checked that I put the wire in the right location on both ends and that it's laying flush against the breadboard. And I'll show you what I mean. Some of the verbiage I'm using right now, we don't use it quite yet, but we will soon in future lectures and once we start getting into the breadboarding, the AOI logic stuff, okay? So we are going to cut everything that we need to, so we will be making sure that we wear safety glasses when we breadboard and making sure that the wires are flush and we are cleaning up our mess. Alright, you're going to have people check for errors. I'm going to show you a couple different ways to check for errors using a multimeter. Alright, and we have a logic probe that's going to just tell you if it's high or low and that sort of thing. I'm going to visually inspect it. You're going to visually inspect it multiple times if it's not working. So I think you guys are going to like when we start breadboarding and doing those sort of things. Alright, the last slide here. This isn't me in the video. There's going to be some other videos of me breadboarding that you're going to have to watch. That way that you know how to do. We're going to breadboard a series in a parallel circuit with the LEDs. But I want you to watch this one a little bit just so you can kind of get an idea before we come into class and we actually sit down and breadboard ourselves. Okay?